Hello, welcome back to the channel. Today we're going to be covering a calculus practice problem for the FE exam. It's on a topic that's a little bit tricky. It is the derivative test, but we're going to explain it in a way that'll help make more sense. This topic actually came up recently in discussion over on our FE exam study community, so I figured it was a perfect opportunity to cover it for everybody. If our study community, lectures, and office hours sounds like something that would be helpful to you, book a free call with me in the description and we'll talk about your FE prep, what's working, what's not, any struggles that you may have, and we'll get you on a plan that is currently working for over 100 students to finally feel confident and ready for their FE exam. That being said, let's go ahead and get started. So in this case, we have a question that says, at which x value does the following function have a local minimum? So the first thing that we're going to do is we're going to go to the FE reference manual. I'm going to have it open right here. And we're going to find the section for the calculus derivative test. In this case, it is a test for a minimum. So a really good way to find that is to just type in minimum and it'll take us right here. Differential calculus test for a minimum, as you can see. So in this case, we're on page 46. We'll zoom in here, and this is the information that we need. Let me go ahead and take that over to our problem, and then we'll continue. So here are the formulas that we just got from the FE reference manual. In this case, we're interested in the test for a minimum, as you can see. The question needs us to find the x value where the minimum occurs for this function, the function right here. So if we take a look at the test itself, we see that it says y equals f of x is a minimum for x equals a if f prime of a equals 0 and f double prime of a is greater than 0. So what this is saying is the minimum for a function occurs at a value x equals a when that value x equals a satisfies these two conditions right here. So the first of those two conditions is going to be f prime of a is equal to 0. So we need to take the first derivative of our function, set it equal to 0, and we'll find what this value x equals a is. That is going to be our first step. So let's go ahead and take that first derivative so we can set it equal to 0. So this is our function right here. F of x equals negative x cubed minus 6x squared plus 9x minus 2. I don't know about you, but I don't like having this negative sign just out here. Let's make this easier to work with by distributing it out. So then we're going to end up with this right here. Finally, we can now take our first derivative. So in this case, the first derivative is going to be negative 3x squared plus 12x minus 9. So now that we have our first derivative, remember that we need to set it equal to 0 to see how we can satisfy this condition here. So let's go ahead and set that equal to 0. Now, in order to solve for the values that equal 0 here, we can use our TI-36X Pro calculator. So let me go ahead and show you how. So here we are at the calculator. It looks a little bit different just because it's the computer version, but it does the exact same thing that the TI-36X Pro you have at home can do. So in this case, we can go ahead and go second and go to our poly solver here. This is a polynomial that we have, so that is why we use this. As you can see, it is going to be a polynomial set equal to 0. Now we go ahead and plug in our coefficients for each of the terms. Our first term has a coefficient of negative 3. Our second one has a coefficient of 12. And then our last one has a coefficient of negative 9. So once we solve, it'll give us the answer for what values of x equals 0. In this case, one of them is 3 and the other is 1. So let's go ahead and write that down. So here we have our two values that satisfy this condition. It's going to be x equals 1 and x equals 3. Now, we can only pick one of these as our answer for where we have our local minimum. The way that we figure out which one has our local minimum and which one has our local maximum is by looking at this second condition that was specified. As you can see, the one that meets f double prime of a is greater than 0 is the location of our minimum, and the one that meets f double prime of a is less than 0 is the location for our maximum. In this case, we're only interested in our minimum. So now our next step is to take the second derivative f double prime, plug these x equals a values into the second derivative, and whichever gives us a value greater than 0 will be the location of our minimum. So in this case, that second derivative is going to be negative 6x plus 12. So now all that we need to do is plug in these values and see which is greater than 0 and which is less than 0. So in this case, let's start off with x equals 1. So we'll do f double prime of 1 is equal to negative 6 times 1 plus 12, and that is going to be a result of 6, which in this case is greater than 0. So this already tells us right away that x equals 1 is the location of our minimum. Just for the sake of completion, we'll do the same thing for f double prime of 3, and that'll give us negative 6 times 3 plus 12, which in this case would be negative 6, which of course is going to be less than 0. So this right here is going to be the location of our minimum, and this is the location of our maximum. And just like I said, the one that we were interested in is the minimum. So our answer is going to be x equals 1, which in this case is B. So just to recap, the way that we solve this problem is by going to the FE reference manual and finding the test for a minimum. Then we use that test for a minimum to find the value x equals a that met these two conditions, f prime of a equals 0 and f double prime of a is greater than 0. I hope that this video was very helpful. We have a lot more videos on the way, as well as a complete system to help you pass your FE exam. Like I mentioned, you can book a free call if you would like to learn more about that. So I will see you in the next video.